Unit 7, Transformations. Here we go with 7.1, and we're going to review shapes, some basic shapes. So three-sided shapes to start with, which are triangles. An equilateral triangle, all three sides are the same, and also all three angles are the same. Okay, we denote that by using these markings here. So if they're all the same, right, 2, 2, 2, that means that each of these lengths are the same. On this triangle up here, this is actually scaling, so that 1 would mean that this length is a certain length. This 2 means that it's a different length. And then this 3 over here would denote that this is even a third different length to the other 2. Isosceles triangle, that means 2 equal sides, and here they are here, and then 2 equal angles. Right-angled triangle, this symbol here is what we use to denote 90 degrees. And of course, if you have 190 degrees, then you have a right-angled triangle or a right triangle. Four-sided shapes we refer to as quadrilaterals. So of course the most basic, or the one that we learned first, is a square. So it's got 4 equal sides. You can see 1, 2, 3, 4, and then 4 right angles. A rectangle, it is different than a square because opposite sides are equal length, right? But not all sides are the same length, and has 4 right angles, also like a square. A rhombus, 4 equal sides. You can see 1, 2, 3, 4, and the opposite sides are parallel. Okay, so the opposite sides here are parallel. Trapezium, 1 pair of opposite sides are parallel. Okay, so we use this nomenclature here, or this notation with these arrows to show parallel, right? And then obviously you can see that these are not parallel to each other. Parallelogram, both pairs of opposite sides are equal and parallel, right? So these ones are parallel to each other and the same length. These are parallel to each other and the same length. And finally, a kite. 2 pairs of adjacent sides are equal. So this side is the same length as that side, and this side is also the same length as this side, okay? And that makes a kite. So this is a quick review of triangles and quadrilaterals. So of course there's a whole bunch of questions we can ask about shapes. Here's one as an example. What could each one of the following shapes be if it has 4 sides? And part A would be opposite sides are equal and parallel. Opposite sides are equal and parallels. Okay, so it says 4 sides. We know we're looking at quadrilaterals. Opposite sides are equal and parallel. Okay, well, that's a square. For sure, that would be one answer, right? Opposite sides are the same length, and they are parallel. So a square would be a correct answer for part A. I'm sure there are more. Let's find shapes where opposite sides are equal and also parallel. Okay, so a rectangle is also a correct answer. And we look further. Opposite sides are equal and parallel. So that's also a rhombus. And let's see if there are any more. Opposite sides equal and parallel. And trapezium is definitely no. A kite is definitely no. A parallelogram, yes. Opposite sides parallel. Opposite sides parallel. Equal length. Equal length. Okay. There's a 4th answer for that one. So, also parallelogram. Okay, B. All sides are equal. Alright, well there'll be less answers for this one. All sides are equal. We can see here that a square has all sides that are equal, and also a rhombus has all sides that are equal. So for B we can write down square and rhombus. Let's look at C. 2 adjacent angles are right angles. Adjacent angles are right angles. Okay, so adjacent means the other side, side by side. Okay, so here we can see from this drawing that these adjacent angles are right angles, 90 degrees to a square. The rectangle, also adjacent angles, side by side, 90 degrees. Okay, so square and rectangle fit the bill here. Now Now, if we look at these shapes, we don't see any others that have adjacent 90 degree. However, we could draw a trapezium that did have that, okay? Because we could do this, something like that, something like that. And so these sides would be parallel. And so this would be a trapezium. And if you drew it well, then you would have adjacent 90 degree angles, adjacent right angles. And so you could make a trapezium that also would answer that correctly. All right. Let's do another question. Example 2. For the grid opposite, name all shapes that are A, congruent, and B, similar to shape A. Okay, so shape A is right here. It's this triangle that's been shaded in. Okay, so first of all, we need to decide what is congruent and what is similar. Congruent means identical. Okay, so that means that when we look at this triangle, the base here has a value of 1 unit, and the height here has a value of 2 units. So if we find other triangles that have 1 and 2, then we've found a triangle that's congruent. Now, similar means that it has the same ratio, the same proportion. Okay? So if one length was 3 and the other length was 6, then we would have found a triangle that is similar to A, but not congruent. Okay, so let's see if we can find any triangles in here that have 1 and 2 for the dimensions. Here's one here, G, that is 1 and that's 2. And anywhere else? K, here's one, this is 1 and this is 2. And if we look further, this one's close, but it's 1 and 3, right, so it doesn't work. And here, L, 2 and 1. Okay, so to answer A, shapes that are congruent to A, we found K, we found L, and we found G. Now we want similar. So that triangle that is of 1 and 2, well, we could have a triangle that's maybe double that. And so we could draw one that's 2 by 4. Or we could draw one that's maybe triple that, and it would be 3 by 6. And we could keep going, make ones bigger. We could even make ones that are smaller, and they would be similar because they scale proportionately to A. So let's see if we can find any on this grid that are 2 by 4 or 3 by 6. Here's 2, and that's 3, so no. Here's 1, 2, 3. Okay, so if this is 1, 2, 3, 4, 5, 6, so C works because this is 3 and this is 6, and so these dimensions are triple the dimensions of A. D is 1, 2 by 1, 2, 3, 4, 5. No, that doesn't work. F, this is 2, and this is 1, 2, 3, 4. There we go. So F is twice as much as A. So F works. And do we have anything else? J is also the same as F. This is 2 and this is 4. So J is also double triangle A. So there we go. The answer to B, similar to A, we have C, F, and J. Find 4 different rectangular enclosures. For each one, find its area. Which shape gives the maximum area? I encourage you to pause the video here and do this one by yourself. 4 different rectangular enclosures. Okay, you're going to use 20 meters of fencing, so that means the perimeter of your fence is going to be 20 meters. And now I'm going to go ahead and do 4. So 20 meters of fencing, and we're going to make a rectangle. So there's one drawn. I can pick any dimension really. So let's say the first one I make, this is 2 meters. That means that the opposite side is also 2 meters. And so I have 20 meters total in fencing that I can use to cover the perimeter of this rectangle. Okay, and so I've already used up 2 here and 2 here, so that's 4 meters total that I've already used out of the 20 meters that I could use. So that means 20 meters minus 4 meters I've already used leaves me with 16 meters of fencing that I can use to fill this line and also this line of fencing. And so they're each going to be the same length. So I can find what they should each be by dividing my 16 remaining meters of fencing by 2, and that will leave me with 8 meters. So each side here would be 8 meters if I randomly put this one together. Okay, so let's draw another one. Maybe similar but longer this way. Let's say we use 4 meters. So of course this one is also 4 meters. So now we've used 8 meters of fencing. So 20 meters total available to us minus the 8 meters we've already used will be 12 meters. Okay, so now that 12 meters is going to make up each of these sides. So if we divide them by 2 because they're each the same length, we're left with 6 meters. So these would each be 6 meters, and that would also make a rectangle that fits the bill for this question. And we could keep going. We could use a whole bunch. Maybe one like this. This is not to scale. Each of these is 1 meters. Okay, that leaves us with 18 meters. So each of these lengths would be 9 meters. And we could do a fourth one. It can really be anything. Let's use 5 because it's a nice number. 5 meters and 5 meters. Okay, that means we've used 10 meters out of 20. That leaves us 10 left, which means, oh, these will also be 5 meters. So we've made ourselves a square enclosure, a long rectangle, and then 2 other sort of medium rectangles. And now what we're looking to do is find the area of each rectangle and then decide which one has the maximum area for the shapes that we've drawn. So I'm going to give us some space here to write that out, and we'll do it in blue. So area for the first shape. To find area, of course, it's width times length. Okay, that's the formula for area. So we're going to multiply 2 meters times 8 meters. And 2 times 8 is 16. And we're working with area, meters times meters. We have meters squared. Okay, so for the first one, the area of this first one, 16 meters squared. Alright, let's do the second one. Again, same formula, width times length. So we have 4 meters times 6 meters. 4 times 6 is 24. We're working with meters and area, so 24 meters squared. Okay, so a larger area than the first one. Even though we're using the same perimeter, it has a different area because it has a different shape. Now the third one, width times length. The width is 1 meter in this case, and the length is 9 meters. So we'll do 1 meters times 9, and that gives us only 9 square meters. That is definitely not going to win this competition. And let's try area 4. In this case, they're all the same. So when I write width times length, I can do, sorry, that should be equals 5 meters times 5 meters. 5 times 5, of course, is 25, and meters squared. So then when we check all 4 of our squares here, this one is 16, this one's 24, this one is 9, this one's 25 square meters. And so in this case, of the ones that we've drawn, here we have the one with the greatest area.